Hi, welcome back, and this is some more examples from section 2.2 of our elementary algebra course. And I'm going to be doing solving some equations, and the technique we're going to see in this video is how to clear those fractions. A lot of times when we see equations that have fractions in them, we freak out a little bit and we get a little bit nervous because we don't like fractions. They make things look messier than we want them to. So what we're going to do is use a technique by multiplying by a number on both sides that's going to get rid of or clear those fractions. So the technique we're going to do is we will be multiply both sides by our lowest common denominator. The lowest common denominator. So looking at all of our fractions, looking at the denominators, we're going to look for that lowest common denominator. In this problem here, our lowest common denominator is an 8. So what we're going to do is multiply both sides, and I'm going to put this in parentheses because we want to multiply the entire side by 8. And I'm going to write this one a little bit strange because I'm going to write this as like 8 over 1 times, and then have this 3, 14 minus u all over 8. Here I will just rewrite it a little bit nicer. So I'll put the 8 right there. So we can see that we're multiplying both sides by the number 8. When I'm dealing with fractions, I might want to put that in fraction form just to make things a little bit clearer for us. And we'll notice that here when we multiply fractions, we can do some reducing ahead of time. And you'll notice that this 8 and this 8 will reduce or cancel with one another. And now I'm going to take and distribute that 3 through. So I'm going to need to take 3 times 14, which is 42, minus 3u. So I'm distributing it to both pieces. Here I'm going to distribute this 8. Because remembering we can just multiply on either side. So I'm going to distribute here as well. So this gives me a negative 24, u. And then plus a 48. It's a little bit larger numbers in this case, but at this point you'll notice there are no more fractions. So we are fine and ready to go with something that we're a little bit more familiar with, namely just, simplifying or solving. So our technique again would be at this point to simplify both sides or each side by combining any like terms that I can. I do not see any like terms. So now I'm going to get my variables on one side. So I'm going to move and add a 24u to both sides here. This would give me a 42 plus 21u equal to 48. Going to move this 42, so subtract my constants to get my constants on both sides. I'm going to move over here. So I get 21u equal to 6. And now to finish this off, we're going to divide by 21. So u is going to be equal to, and I'm going to reduce this. They both have a 3 in common, so this would be 2 sevenths. And again, I want to remind you, you can go back and substitute and make sure things work nicely. If you want to substitute to make sure that it does check. Okay, I'm going to go on and solve another one. Again, the process is to clear those fractions, that out of the way, by multiplying by the common denominator. So that lowest common denominator, looking at the 3 and the 4, so our lowest common denominator is a 12. And so we're going to multiply both sides by 12. Okay, since I have fractions all over the place, I'm going to write that 12 in its fraction form, namely 12 over 1 times my 2/3 here. I'm going to distribute this 12 into both pieces. 12 over 1 times my negative 2/3 x plus that 12 over 1 times 3 over 4. And now I'm going to do some reducing ahead of time. So my 3 and my 12 gives me a 4. The 3 and the 12 gives me a 4. The 4 and the 12 gives me a 3. Be a little bit careful not to lose my variable x. Notice it's sitting right there. Very easy to miss some things. And as you get stronger with the more practice that you do, some of these little steps that I'm putting in are ones that you might be able to leave out. But as you're getting comfortable, put the steps in because it's all about the steps, because that's where you're going to make the mistakes if you start leaving some of them out. So here I have 4 times 2, which is 8. There's my equal sign. Here I have a 4 times a negative 2, so it's a negative 8. And don't forget your x. And here we're going to have that plus 9. Now I want my variables on one side, my constants on the other. My variable is on one side, so I'm going to undo this adding 9 by subtracting 9. So I get that negative 8x and that negative 1. Dividing both sides by negative 8. Negative divided by a negative is a positive. So I get that x is 1/8. And we should feel comfortable with answers in fraction form. I usually leave my answers in fraction form as opposed to decimals because they will be more accurate. 2/7 in its decimal form goes on and on forever. I know 1/8 does not, but so 2/7 is more accurate than its fraction form. All right, let's do a couple more, just so we can get more practice clearing our fractions. So we're looking for that lowest common denominator. We have a 4, a 2, and a 3. So again, that lowest common denominator between the 4, the 2, and the 3 is 12. So we're going to multiply everything, both sides. We have big sides this time. It's by that 12. So both sides, and again, I'm going to do it in fraction form where I need to, so I'm going to distribute this. So we're distributing that 12 into both pieces. So 12 times the 2n, that gives me 24n. It's not in the fraction form, so I'm just going to do that one right away. Then we have this minus, and I'm going to write this 12 over 1, the 3 over 4n equals, distributing here my 12 over 1 times my 1/2. And again, like I said before, some of you might be able to skip, whoops, this is a 3. Skip this part, and go right to this next piece because you would do that reducing, but I'm going to do it here. I'm reducing my fractions, and I'll have 24n minus 9n equals 6n plus 4 times 13 is 52. Okay, and if you need to dig out your calculator to do 4 times 13 just to double check, feel free to do so. I'm going to clean up both sides. So I'm going to take that 24n minus my 9n. That gives me 15n. I'm going to subtract 6n to get my n's on one side. So I have 9n equals 52. I'm going to go over here. 9n equals 52. I have to undo this multiplication with division. 9 or n is equal to 52 over 9. I do believe that that is reducible. Maybe, maybe not. Okay, it does not reduce, so this is 52 over 9. So you can leave it in its improper form, Or if you want to rewrite it as a mixed number, that would be 5 and 7/9. Okay, I have one more for us to practice, and it's x plus 7 is equal to 2x plus 6 all over 2 plus my 4. So our lowest common denominator again, because we do not like to see the fractions, is 2. So we're going to clear those fractions. So we're multiplying both sides of our equation by 2. Okay. I'm going to do a little bit more this time without writing all of the steps, just so that we can see these things. So this I'm going to distribute. So I'll get my 2x plus 14 here. I'm going to distribute this 2 into both parts. So thinking this is going to be multiplied by 2 over 1. Those 2's will cancel. I'll have that 2x plus 6. And my 2 times that would give me a 4. Cleaning up both sides. 2x plus 14 equals 2x plus 14. Getting my x's on one side, or my variables on one side, I'm going to subtract 2x from both sides. And I get that 14 is equal to 14. This is a true statement. This is always true. Which means that no matter what value of x I substitute in there, I will get a true statement. So that means my solutions, and I do have more than one, will be all real numbers. So no matter what real number I put in there, I could put a really ugly number in there, like the square root of 4. That's not ugly. Square root of 5, and that one would work. I could substitute 57/4, and it would work. I could put in a negative 5,262, and it would work. So any number that I wanted to stick in there would create it to fall out the same way, and we'd get a true statement. Hopefully these examples helped a little bit, showing you how to clear fractions so that you feel a little bit more comfortable with that process. I will see you in future videos.